Alright, so I've done a number of videos now using this unbelievably interesting method, one that I'm still trying to figure out why we aren't taught this method in schools. Why weren't we? Even though this method is so old, yet no one has taught it in school. So I'm just going to apply this method now to quadratics that don't have a greater, that a is not 1. So any number where a is bigger than 0, so a bigger than 1. So let's see what happens. So here's a problem. I've kind of made an easy one first just to take you through the process. So 2x squared minus 12x minus 110. Now, the key thing to remember here is that if there's a coefficient of x squared, we need to divide by that before we apply this method. So in this case, we'll divide by 2. So if we divide by 2, we'll get x squared minus 6x minus 55. The moment you do that, we're now back into the similar kind of problem that was discussed in the other videos. So I don't want to, if you haven't yet seen my other method, then this might be a bit fast, but you'll still think, well, that's a cool method. But if you really want to understand the method, you need to go back to my earlier videos where I explain those a little bit more detail, step by step. But first of all, we'll focus not on the product, we'll focus on the sum, the number in the middle. So we get to the middle number and we say, what two numbers add to get 6? Because of the practice that we've been doing, we know that the two numbers that add to get 6 will have this format, 3 minus m and 3 plus m. This will always happen. There's always a pair number that has this setup. So it doesn't matter what m is, as long as we have the same number added and subtracted from 3, we'll end up with 6. For example, if m is equal to 1, 3 minus 1 is 2, and 3 minus 1 and 3 plus 1 is 4. So we still get 6. So it always works. These are two numbers that add to get 6. These two numbers that add to get 6 should also, if multiplied, give us the number at the end, which is minus 55 in this case. So we've set this problem up based on how quadratic roots, the roots of equations, are always set up. The roots always should add to get the middle number and multiply to get the last number. So we're going to apply that in this way. So we expand to find our specific m, and we'll end up with 9 minus 55, which will give us 64. Square root gives us 8. In my earlier videos, I've explained that 8, it doesn't matter if we use minus 8 or 8, as long as we consistently use one of them, because the answer will be the same. In this case, we'll stick to 8, and so our final answer is going to be 3 plus or minus 8, and that means we get 3 plus 8, which is 11, and 3 minus 8, which is minus 5. And that works. That's a solution. Done. Doesn't matter how complex the problem is. It's going to take you 1, 2, 3, 4, 5 steps. Yeah. So I'm going to look at this one now. I've kind of jumped the step on this one because we have 3x squared minus 15x plus 1. Again, we just divide through by the coefficient of x squared. In this case, it's 3. So 3 into 15 is 5. And then we have 1 over 3. Now, that's the problem now. We've just kind of made it simple so that we can apply this method. Again, we focus on the middle number, which is 5. We're going to find two numbers that add up to get 5. Now, half of 5 is 5 over 2. So it will look something like this. 5 over 2 minus m and 5 over 2 plus m. These are the numbers that will always work to add up together to give you 5. We know that when we multiply these two numbers, they should give us the last number, because that's the conception of a quadratic, the way the roots are organized in a quadratic. Expanding 25 over 4 minus m squared is 1 over 3. And then we know that if we subtract 1/3 from 25 over 4, we get 71 over 4. Now, how I do it, I have a very simple method to do this. I can do 25 multiplied by 3 and 4 times 1, and I know that 75 take away 4 is 71. But you can use a calculator if you want to, or you can just set up fractions to do it. That part is a matter of competence here. And then the answer is root 71 over 2, because we've distributed the square root, and square root of 4 is 2. Plus and minus 5 over 2 plus or minus root 71 over 2. Alas, or 5 plus root 71 all over 2. It's finished, it's done. So again, this method is amazing. This method is really, really cool. If you're interested in learning, solving quadratics and having challenges using the formula, then this method will always work. It's an amazing method, it's old. So I have a number of videos going through easy ones, and I have some going through some challenging ones. I think it doesn't get any more challenging than this. This is literally maybe the hardest a problem can be, really, and so yeah, it's just like this. It just worked through it like this, and It should be fine. So I leave it with you. So just have a look at the other videos if you wanna. My last video I'll do in this series is the proof of the quadratic equation using this method, because that's going to be important for you to understand if you're moving on into higher level math. It's good to know how the proof is organized. In fact, this is maybe one way in which everyone can learn how to prove the quadratic, because it's so intuitive. So I'll leave it to it, and I'll be leaving you now, and just subscribe if you wanna, or just like or watch more of the other videos using this method and apply it. This is 5 steps, 5 easy steps. If it's fractions, a little bit more, but 5 easy steps. So peace out.